is ancestors in a binary tree. So what is this problem is? So we will be given a binary tree and no ancestors of a nodes X is node Y. So first I'm going to write the inferences what I can get out of this problem statement. So ancestor of node X, and here you can write an ancestor column. Okay, ancestor of node X is node Y. Node X is node Y. Okay, which is at the upper level of node X and X is directly connected to Y. Consider multiple levels of ancestor to solve this problem. In case there are no ancestors available, return an empty list. So agar say for example we don't have no ancestors, then return empty list. Okay, so what this problem is, see they have given a hint list, so we have to solve this problem using the concept of array list. Okay, we'll be having a list and in that list we are going to add the ancestors. So first of our task is to check the node whether the node has some value, then we have to traverse to the left elements and then we have to traverse to the right elements and then we have to add the elements to the list. Okay, add ancestors to the list. Okay, add ancestors to the list. So how we are going to do this? You can see we are given a binary tree 1 2 3 4. Okay, let me just construct a binary tree quickly. So the binary tree is 1, then we have 2, and then we have 3. Okay, and 2 is subdivided into 4, and 2 is subdivided also into 5, and 3 is subdivided into 6. Okay, and it's also subdivided into 8. So we will be it's kind of like a linear search algorithm. Okay, so ancestors in a binary tree, we can traverse a binary tree with a we can check our worst case and best case time complexity. Okay, so for our worst case time complexity, we can see for a binary tree it can be O log n. Okay, the time complexity can be O log n. Let me just check first and then we are going to work with this. Okay, so main target is we have to check our target element. Our target element right now is 7. So whenever we have a target element as 7, say for example over here we have a target element as 7, that means there is some value. So 7 is one value. Okay, so we have to return all the upper levels of this 7. So whether 7 lies on the left or right we don't know, but we know one thing, that we have to return everything which is on the upper deck of this particular 7. Okay, so our algorithm should be like, first we have to find the ancestors. Okay, and then we have to add elements by traversing. So we can have left. Okay, in left we are going to add root dot left values. Okay, and right we are going to add we can say root dot right values. Next we are going to check whether our element matches to the target element. So if, say for example, wherever I am and our ancestor is present, say for example 1, so it matches, and our target value which we are passing to the user is also 1. So user will give a value and we have to check all the upper deck. So that is right. Like, so in that case we are going to return true. If our target is equals to root dot data, means the current value. But if it is not there, then we are going to traverse the left side and the right side and we are going to do the OR operation. We are going to do a Boolean operation to check whether it is lying on the left or right. In either case, once the value is found, we are going to add abc dot we can add root dot data. Now what is abc? Now there are a lot of questions coming in your mind, I know. abc is nothing but we are going to define a array list. Okay, in Java we have an array list, and C++ you can have a vector. So this abc is the list where I am going to add all the data elements of this root as I get. Okay, so let me just quickly solve this particular problem, how we can solve. So you can see first there is a default constructor. So this is a default constructor which is driver code. Okay, over here it is telling you how you can initialize the data we are getting from the user. Okay, the user is going to pass a key and that key is initialized, and initially there is no elements, no left, no right, no nothing. Okay, now we are making our main function which is an array list function. So in this array list of type integer we are going to add all the ancestors. We are going to have a root, we are going to have a target, we are going to have a root, and we are going to have a target. We are going to store it in an array list known as ancestors, and in this ancestors we are going to call our helper function. You can see this is our helper function. Helper function. We are going to pass a root, we are going to pass a target, and we are going to pass the ancestors. And finally, we are going to return all the possible ancestors. So how I'm going to find the ancestors? So ancestors, we have to find it with a true or false values, right? We have to find the ancestors in a true or false values. We have to check whether the ancestor is actually the ancestor or not. Whether, say for example, over here I am going to find 7, but I am getting 6. X is not the ancestor of 7. The ancestor of 7 is 4, but how we are going to determine it? So this code, this helper function is all about that. So what we are basically doing is, we are first checking if our node is equals to null. Then we are going to return false. If there is no value we have, then we are going to return false. Now I said if our ancestor is the target value, if 7 is what 7, and there is nothing on top, there is no levels on top, then we are going to return true automatically. Okay. Now what we are doing is, we are using a function find left. Now we are recursively calling the find ancestor function, and then we are checking that whether my left node.left value means node.left value is nothing but this value. If this is my root value, if this is my root value, my node.left is 2. So I'm checking whether my 2 comma target, okay, comma ancestors. In this function, what I'm passing is a target. Say for example, a target right now is 7. Okay, so I will just make it easy for you guys to understand how this is working. So initially, find left equals to, it is saying find ancestor, means here recursively calling this function is saying that pass the node.left. So my node.left is nothing but 2, right? My node.left is nothing but 2. So I'm passing 2, and I'm passing my target value 7, and I'm passing the array list ABC. Okay, now I'm going to check it. Node.data, my current node.data is 2, right? Is 2 equals to 7? No, my 2 is not equals to 7. Then I'm going to find right. Okay, also in the find right, node.right. So I have to go node.right as well. So my node.right becomes 3. So in the node.right, what I'm getting is I'm passing a value 3. I'm passing a value for node.right. So for left, I can say this. For right, I'm passing a value, say 3, 7, and ABC. Okay. If find left or find right, ABC dot add node.data. So if any of this condition is true, where my target value lies, I'm going to add node.data. So in node.data, if you see, my target value is on the left side, which is 7. So in node.data, I'm going to add abc.add. So in my list, my first element which I'm going to add is if you see is 2, right? If you see is 2. Okay. Similarly, this process will continue, and eventually I'm going to get if the data is true, if this is true, if I'm getting the data, if the operator is checking whether I'm getting the data, if it is true, I'm going to return true. And if it is returning true, then it is also adding the elements at the same time. So finally, I'm going to get all the values 4, 2, and 1, which is 4, 2, and 1. I'm going to start from here, 2, 1. So 4, 2, and 1 is my default answer. Okay. So I'm going to quickly solve this particular problem in the code directory and try to see how we are getting it. Okay. So initially, I'm going to just delete this. This is not required right now. And yeah. So this is what we had initially, right? This is what we had initially. So first I'm going to define an array list. Okay. An array list. I'm going to define an array list of the type integer equals to new array list. Okay. Now once I get the array list, now I'm going to find my ancestors. So I'm going to call this function find ancestors. Okay. Find ancestors, or I can write like this, find, just find function. Okay. In the find function, I'm going to pass some values. So I'm going to pass my root value, I'm going to pass my target value, and I'm also going to pass my array list. Okay. Because I'm going to find it, and I'm going to return this ABC, which is nothing but my target value. Okay. So this is my first task, but my function is boolean function, because I'm going to check whether it's true or false, right? So boolean, I can say it is find. In boolean find, I can pass a node. Okay. What else can I pass? I can also pass a target value. And I can also pass an array list. Okay. I can also pass an array list, say ABC. Now in this find, I'm going to check if my node dot data, no, first I'm going to check if the node is equals to null. Then I'm going to return. Okay. Now I'm going to check if my node dot data is equals to target. I'm going to return true. Okay. Further, I'm going to also check a boolean left check. A boolean left, as I told, is going to recursively call this find function, and I will have node dot left, I will have my target, and I will have my list ABC. Boolean right value will be also there, equals to a find value, a node dot right value, a target, and an ABC. Now I'm going to check if left or right. If this condition gets fulfilled, what I can do is I can clearly, if my left is, I can add. So ABC dot add node dot data, okay, and return true. So yeah, let me just check. Where's a blank return, missing a return value in line 128. So I'm going to just check what I did. So return false. Okay, so it's a small mistake I did. If it is null, I have to return false, and also return false if the conditions don't satisfy. Yeah, I'm going to quickly submit. So if you see, my code successfully passes all the test cases. So this was about today's problem statement. I hope you could understood this problem statement, and we are looking forward to solve more problems. Thank you.